All right, hello. So I had a classmate that's having trouble with their code and asked me to take a look at it. So here I am recording a screencast of me uh, debugging their code. And the code in question is in chapter 2. We wrote the script. We called it car update. So we're tracking the passage of cars between Albany and Boston. And so it's just example 2, 3. So I think at time equals 0, we started at 150 cars in both Albany and Boston. But then we learned that the number of customers picking up cars, and let's see, 5% of the cars in Albany are dropped off in Boston, and 3% of the cars in Boston get dropped off in Albany. And so we're asked to create a script so that after a passage of 1 week, we can calculate the number of cars in each location at the end of the week. Um, and then, you know, in chapter 3, we took that a step further to try and use a for loop so that we could automate the modeling of multiple weeks and then also to plot the results. And even in chapter 2, right, our script, right, is here, right, in that case to solve. But yeah, all right. So let me take a look at the code that was sent to me, and let's have at it. So we have the script to track the passage of cars from Albany to Boston. Precondition: a number of cars in Albany and Boston at the start of the week, a number of cars in Albany and Boston at the end of the week. And so here we're initializing, which is good because then we have that for loop to simulate some number of weeks. It's actually a precondition in this case looks like it's none, since the number of cars in Albany and Boston are specified. So we have the number of cars at time equals 0, and then we're trying to plot the number of cars at time equals 0. Okay, so week 0, the number of cars. Okay, well, it looks like we're plotting Boston twice, which is fine, but not rigorously correct. So I'm just going to change one to Albany, one to Boston. Star, so that should be plotted. The symbol's going to be star red. Okay, this is a 0. I think for circle it needs to be O. Okay, but we'll find out. Then you're looping for I equals 1 to 55, circuit model 55 weeks. And so here we're tracking the number of cars from Boston to Albany. So that's 3% of the cars from Boston get dropped off at Albany. 5% of the cars from Albany get dropped off in Boston. We're taking in 2 separate steps. So the new number of cars in Albany is the original number plus the 3% from Boston that get dropped off in Albany minus the 5%. So this is slightly off, right? So this, right, just needs to get replaced with these variables that we've created. So the number of cars in Albany at the end of the week is the original number of cars in Albany at the start of the week, plus this is the 3% of cars that started in Boston and were dropped off in Albany. That's what we called here B2A. Okay, it's 3% of the original cars in Boston at the start of the week, and then we round that to eliminate any rounding issues since cars need to be, full countable cars. Then this is minus. Okay, so it's minus the number of cars that start in Albany and get dropped in Boston, which is 5% of the cars that begin in Albany. So this is actually A to B. So then B new is the number of cars that I have in time equals 0 in Boston, minus, so this is the number of cars that begin in Boston and get dropped off in Albany, so it's that same B2A. Okay, then plus, so these are the cars from Albany that end up in Boston. So that's A to B, and it's positive because we're gaining cars here. And then what we need to do is, this is the number of, cars now in Albany and Boston at the end of the week. We had created new variables A new and B new only because if I look at the right hand side, my expressions are dependent on A and B, right? And so we added in class new variables to try and prevent accidentally overwriting A or B and then messing up that calculation for the other city. And so then what we did is after we did that, we just said A, right, the number of cars at the end of the week is A new, and then B is equal to B new. right? And I'm sure I could have done this in less lines. Even looking at the solution we had in chapter 2, it required less lines, but this works, this makes sense, right? All is good. And then in class, we had cleared A new and B new just because they're kind of intermediate variables. And I could do that in the for loop, or I could actually take it out of the for loop since it's only after that final iteration that I'm worried about it. Okay. All right. And so I could run this, but if I were to run this, I would want to display the results. So let me just plot them though, so that we get this working. All right, so now to plot. So coming up here, we plotted the number of cars at time equals 0 in Albany. Now remember though, so as soon as I have this first plot command on line 10, it's going to open up a figure window. So it's going to open up figure 1. It's going to plot my first data point. Now in MATLAB's head, right, we're plotting data points here in our mind. And these are sets of data in MATLAB's mind. So every time I plot a new set of data, the default behavior is to clear all of the other sets that are currently plotted. To override that behavior, I need a hold on command. So hold on command can come before line 10 or before line 11. It doesn't really matter, right? So if I were to test in the command window, just typing on hold on, that'll also initiate opening up figure 1. Right, on mine, it just opened up in a different screen. Okay, so the hold on could come before my first plot command, or it could come after that first occurrence, which then just tells MATLAB, okay, don't clear any series out when I plot new data sets. Okay, so I've got to hold on. Okay, that's great. And then I'm going to copy and paste this now that hold on is on. And I'm going to come down here. I'm going to paste it. Okay. Now the only thing I want to do is instead of plotting the number of cars in Albany and Boston versus 0, or week 0, I want to update that to be the end of my current week, where my week corresponds to my loop index variable. Okay. So remember my loop, the first iteration. Okay, so I have some initial number of cars in Boston and Albany. I enter my for loop. So when I enter the loop, I'm going to start by assigning a value of 1 to variable I. All right, perform the calculations between 4 and end. Okay, I is not equal to 52, so it's going to cycle back. It's going to update the value of I by 1, so then it's 2, repeats, and so on and so forth. All right, so I, which is keeping track of my iterations from 1 to 52, in this case also physically corresponds to the week number. Okay, so what I'm going to plot A and B against is I, which is the week number. Okay, I have the hold on command up there, so this should work. Okay, so now I'm going to run it, see if it works, and then we can go and we can think about adding axes and such. So if I run it, my figure pops up in another window. All right, looks good. Okay, cool. Okay, now one interesting thing is if I leave this up, right, and I plot again, is I'm going to change these colors just so we can try and see the effect. Okay, I'm changing them both to black. If I don't close my figure window, oh, I only changed plot point 0. Hold on. If I don't close my figure window, okay, what happens, and actually I might not see anything, is I'm just plotting right over my other data set. And actually that wasn't a very good example, just changing the color, because these points are lying directly on top of the other ones. Okay, and so you'll notice that I close my figure a lot. Okay, and that's just so that I make sure I'm starting fresh. Okay, the other thing you could try, right, is if I know everything's going to be in figure 1. Okay, I could start out with the CLF command, which will clear my figure. Okay, that way it'll open up my figure window. Then if there's, or activate figure 1 if it's already open, and it'll start by erasing anything that's currently there from when I run it this first time. Okay, but that's a small detail, and it's hard to notice here, but that comes up a lot when you run your code once, you make a mistake, and then you don't close your figure window, you fix the mistake and run it again. The way your plot looks might make you think that there's a mistake, right? When really there's not. Okay, so let me just close that, but CLF is another way to achieve that. All right, so now in terms of formatting, okay, I could add my formatting, after I open up my figure, okay, or once everything's there, I could also add it there. It doesn't make a difference, and so I'm going to add it at the end. So to format my graph, I'll start with an X label. Okay, so X label is my X-axis label. Okay, it's a function, and the argument I need to give to is a string. And so X label is week number. My Y label, okay, the Y-axis label, this is the number of cars. Okay, cool. If I want a title, it's a title. And so the title will be I don't know, rental car tracking. I think of something better. And then the last thing I'm going to add is a legend. Okay, so legends are a little awkward at the present moment since we're just plotting individual data points. But the legend's my function, right? And then what I can pass to it is labels for each data set in series. Now remember, every time I plot I call plot, right? MATLAB interprets this as plotting a new set of data. So in this case, right, this is set 1, this is set 2, okay? Then the first iteration, this would be set 3 and 4, and that would keep repeating until I get to my 50-second week. And so really I have 106 sets of data in MATLAB's mind, when in our heads it's only 2. And so what I'm going to do is I'm going to add a label for my first 2 data sets. So the first one is Albany. Okay, is data set 1, then data set 2 is Boston. Okay. This will be easier once we plot or store our data to vectors and then plot, as I'll just have a single set. I'll store all of the cars in Albany to vector. I'll do the same thing for Boston, and then I'll plot that entire set at once, which is more like what we would think. Okay, but for now, this should work. And so if I run it, okay, now I get my figure window. Great, in terms of number of cars, week number, rental car tracking. Right, I've got my legend here now as well. And yeah, that's about it. And just for a bonus while I'm talking, right, if I want to get in the habit of saving my figure, okay, remember the save fig command. Okay, I just need to give as an argument a string, so a name for my file. So maybe I call this car tracker.fig. Okay, so just like we call our script an M file, a fig file is a MATLAB figure file. Okay, and so what that means is if I run this, okay, I pop up my figure, but then I also see this new car tracker fig that appears over here. So a fig is a MATLAB editable file. And so if I double click on fig, right, it'll open back up, a figure window of what I had. Okay, so fig is a MATLAB format of a figure that I can open up and edit. But this isn't something I could insert in, say, a lab report or anything like that. If I wanted to, and actually I'm going to double click on it, if I wanted to save it as something I could put in a lab report, okay, remember save as up here is another way you could save it as a fig, or on the drop down you see that MATLAB knows or could also save in various image formats. Okay, and so you could look at those there. Okay, I can't remember all of them. Okay, the command to save as an image, something I could put into a lab report, is with the print command. Okay, I'm going to bring up the doc page, okay, because the doc page will have more information than we could possibly want. Okay, but it'll also have summarized, so they have these bitmage image file formats, and so it tells you what type of image it is, right, the extension, and then it shows you what this option command is that you need in the print command. So if I wanted a PNG, it's actually a flag, but it's dpng, not just png. Okay, they also have vector graphics where they all begin with D as well. Okay, and so I always come back here because I sometimes forget, that it's a flag -D and then the file format. Okay. So the print command would just go print, and then I'm going to specify the file format. So let me try dpng, comma, and then the second argument is just file name. Okay, and so I'll call this car tracker.png. So now when I run this, okay, I have my figure 1 that pops up. Okay, still just the fig there, but I have this PNG, and if I right click, well, I see a little preview down here. But if I click to open outside of MATLAB, you should use your default image viewer on your system, right? And I can see my PNG, which is now an image that I could insert into Lab Report. Okay. And I'm pretty sure with print, I don't think the order matters. So if I were to delete this PNG, okay, just so I test it, I'm pretty sure the option where I specify the format, I think that could also come second. So let's try, and let's see what happens. In the spirit of unit testing. The spirit of unit testing, there it is. PNG, yeah, PNG still works the same. So in terms of print, the order in which the name and then the file type or image type goes doesn't seem to make a difference. All right, hope that helps. Let me know if you have any other questions, and I will see you in class today.